Today we're going to be talking about wiring up the 210 wiring board for the outside unit. You're going to start with your disconnect. First thing you want to test is your line voltage to make sure your meter is on a VAC setting. Line voltage gets its power from the actual breaker. You're going to read your 210. When you go to your load voltage, you will not read your 210 because the disconnect piece is not in right now. You're getting a reading of 2.7, which really doesn't matter right now. It means you have a little bit of voltage leaking through, but at this point it doesn't make a difference. Whenever I put my disconnect in, that's when I'm going to actually get my 210 reading. Disconnect is in, and now I have 210 on my load. So you start on your line, and then your disconnect goes in, and then your load voltage picks up the power and takes that power to the bottom of your contactor. Bottom of the contactor, now I'm reading my 210 reading. The next thing I'm going to do, take my disconnect out, and I'm going to start testing my actual switches and loads up here. I'm going to start with my thermostat. I need to have one lead attached to the R because R brings power into the thermostat, and the two switches I'm worried about are going to be my yellow and my green. Alright, I'm reading less than 1 ohm, so that lets me know that's a good switch. From R to yellow is good, so that means anytime I send the power and put it in the car for cool, the power should energize my contactor. Alright, the next terminal I'm going to read is going to be my green terminal, which is going to energize the indoor fan. So I'm going to make sure that is actually closing. I'm reading less than 1 ohm because it's a switch. I'm reading less than 1 ohm, so that's also operating properly. If I read OL on any of those while I got it in a car for cool, that means the actual contacts are closed, or are open, or have bad thermostat wiring. OL reading anytime in the car for cool is a bad reading. I should read less than 1 ohm. The next thing I'm going to test will be my actual transformer. Transformer brings your power in as 110 and steps it down to 24 volts. I'm going to go from my neutral to my high. Neutral to high, I should read resistance. I'm reading 19.9, which is mean it's close to 20, but it's a good resistance reading. If I read OL, that means I have a bad transformer. Then I'm going to test my secondary. Secondaries are 24 volts when we step that 110 down in the transformer. Secondary is reading 1.3, so that let me know the secondary side of the transformer is also good. Alright, the next thing I would like to test is the coil on the contactor. The yellow signal from the thermostat comes to the contactor and is actually going to energize the contactor anytime I put it in the car for cool, and it's going to pull this button in right here. The contactor coil, I'm reading 18, so I have a resistance reading greater than 1 ohm. So that let me know that I have a good contactor. If I read OL, that's a bad contactor. Contactor should always have resistance going through it. Anytime I put it in the car for cool, it should always have resistance going through it. Anytime I test it, anytime I put it in the car for cool, it should be able to pull the button in and allow the contactor to energize. The next thing I'm going to test is my two different sides of my contactor. I have the solid strip side, which will always allow power to pass, and then I have the push button side. The push button side, you must have this energized with the yellow terminal running through your contactor and common on the other side in order to actually pull this button in. That is a normally open switch until that button is pulled in, so I should read OL. Alright, anytime I push the button in, the switch should close and I should get my 0 reading. Less than 1 ohm. Alright, on the side that is always passing power, I should automatically have my 0 reading on that side. I should never read OL on that side. If I do, that is a bad contact. Alright, the next thing I want to show you guys is the capacitor. You got to change the setting on your meter over to a MFD setting to test this capacitor. On these capacitors, it's pretty universal. The 4 prongs on your capacitor will be your common. The 3 prongs will be your herd. The 2 prongs will be your fan. Some of them also come with this little piece right here that's going around the little prongs in different colors. Green will be fan, black will be common, and white will be herd, which is basically hermetic compressor. Alright. I'm going to always make sure I go from common to whatever I'm trying to test. So I go from common, and sometimes you have to put your leads on there multiple times to get your actual reading. I'm going to go common to fan, and there's my 4.9. This is a, I think this is a 5 microfarad capacitor for my fan. It says 5 MFD for fan. Alright. The next thing I'm going to go from my common to my Herman. Like I said, sometimes you have to put it on here multiple times to get your reading. Alright, there's my 40 MFD. That's what I'm supposed to read for my compressor. 40 MFD is for the compressor, 5 MFD is for the fan. So this is a good capacitor. Alright, the next thing I would like to test at this point, I'm going to come on over here to my actual relay, which will not be located on the outside unit, but I just want to show you how to test a relay for a call for the fan to come on, which we're energizing the call for cool, or if you turn your fan on your thermostat. The bottom part is where your coil is, so I should always read resistance. Got to change the setting back over to resistance. I'm reading my resistance at the bottom, 18.4.5 is what my resistance is. Number 1 to number 2 should always be closed, so I should read my 0. Number 1 and number 3 should always be open, and I'm reading OL. Anytime this is energized with the G terminal, number 1 to number 2 will change to a OL reading, and number 1 and number 3 will change to a resistance reading. The next thing I'm going to test is going to be my outside fan. It's a 220 motor. And these are normally universal. The colors can change though, but in this case right here, I'm pretty confident in the color code on this fan right here. Black should always be your common, and brown should be your start. So I'm getting a resistance reading of 48. From black to brown, I'm getting 48. From black to purple, I'm getting resistance of 34. Always remember, whenever you go from your common to your 2 leads up here, the one with the highest resistance will always be your start. The one with the lowest resistance will be your run. Even though the values were pretty close together, the brown clearly had a higher resistance than the purple. So that makes brown my start, purple my run, and black will actually be my common. So as long as I know my common, I can figure out the other 2. The next thing I'm going to go to is going to be my compressor. Alright, this compressor has a little cap on it that tells me common, start, and run. And also off to the side of the compressor, you have this thermal overload protection on here. It's basically tied in with the common. Anytime it overheats, it's going to kill the power to the compressor. If you want to ohm a compressor out, you can use the same principle that you use on that fan. You can go from common to your other 2 terminals up here. In this case, I would say T1 to T2. I'm getting a resistance reading of, what's that resistance reading?
6.4.
Alright, I'm getting a resistance reading of 6. Alright, I'll go T1 to T3. What am I getting a resistance reading of? It's kind of jumping around, so I'm going to actually put these leads on here. That'll help me get a better resistance reading. Alright, I go back to my T1 terminal, and I go from T1. I'm always going to make sure T1 is in the circuit because it should be my common. Alright, that should be T1 to T2. I'm getting a resistance reading of 6. T1 to T3, I'm getting a resistance reading of, let's say, 1. So according to this little cap right here, common should be this one, start should be, common should be T1, start should be T2, and run should be T3. Common to T1 had the highest resistance, T1 to T2 had the highest resistance, so this is my start. T1 to T3 had the lowest resistance, so that is my run. This right here is your thermal overload protection. Anytime it overheats, It's going to actually open up the circuit by opening up this common leg by killing the power there, killing the power to the rest of the compressor. So that's how the thermal overload works, by stopping that common leg from getting the power. That is your compressor, and that's the final thing we must test in order to make our outside unit run.